In part 3 of our lesson on using the trig function definitions, you're going to learn how to find the ranges of the trig functions. If we consider theta to be an angle in standard position, we know the length of the terminal side is r. Now from this point, xy, we're going to drop a perpendicular so we get this right triangle. Now, the x and y coordinates may be positive or negative depending on whether you're in quadrant 1, 2, 3, or 4. For example, in this case, our x coordinate would be negative, but the length of a side of a triangle, of course, has to be positive. That's why we have absolute value of x here. So in the most general case, we're always going to call the length of this side absolute value of x, the length of this side absolute value of y. Now we know in a right triangle, the leg is always going to be less than or equal to the length of the hypotenuse. So it's safe to start out with an inequality that says the absolute value of x must be less than or equal to r, because it's just saying this leg has to be less than or equal to the hypotenuse. In your algebra class, you learned how to rewrite this inequality without the absolute value symbols, and it's negative r is less than or equal to x is less than or equal to r. Now we can divide the whole inequality by r. We get negative r over r is less than or equal to x over r is less than or equal to r over r. And we got to keep the inequalities the same because we know that r is a positive number. So we're dividing by a positive. We don't have to switch the inequality symbol. The inequality symbols stay the same. Now when we simplify this, it becomes negative 1 is less than or equal to, now x over r, that is the definition of cosine theta, is less than or equal to 1. So what we just discovered is that the range of the cosine function is negative 1 to 1. So cosine will never be smaller than negative 1 or bigger than positive 1. Now similarly, we know the length of this leg, which is absolute value of y, has to be less than or equal to the length of the hypotenuse. We can get rid of the absolute value again by turning this into negative r is less than or equal to y is less than or equal to r. We're going to divide through again by r as we did before. And now negative r over r becomes negative 1. Y over r, that's the definition of sine of theta. And r over r is positive 1. So we just discovered that the range of sine of theta function is from negative 1 to 1 as well. So to summarize, the range of cosine theta is negative 1 to 1, and the range of sine theta is also negative 1 to 1. And this, of course, is using interval notation. This stands for is an element of the set, and this is a shorthand way of writing. So we say cosine theta is an element of the set negative 1 to 1, sine theta is an element of the set negative 1 to 1. That's their ranges. Now, tangent and cotangent have x and y in the numerators and denominators. We know that the y value could be positive or negative or 0. We know the x value here could be positive or negative. It can't be 0 when it's in the denominator. But when we think about fractions, we know that as the numerator of a fraction gets smaller, or as the denominator gets bigger, we know the fraction gets smaller. So we know tangent theta could take on very small numbers. Likewise, if the numerator gets bigger or the denominator gets smaller, then the fraction gets bigger. So y over x could be a very small number. Y over x could be a very large number. It could also be positive or negative because x and y take on positive and negatives. It could also be 0 because y could be 0. So it could be 0, it could be very small, it could be very large, it could be a tiny negative, it could be a huge negative. In other words, these rational numbers, which is what y over x is, or x over y, same argument for x over y, they can be anything. So the ranges for tangent and cotangent are all possible values, all real numbers. So the range for tangent theta is that it will be contained in negative infinity to positive infinity, and the same for cotangent theta. And again, that's because the rational expressions could be tiny little positives or tiny little negatives, could be very large negative or very large positive. We know y over x could be 0, y over x can be positive, y over x can be negative. So there's nothing this thing can't be. It can be 0, it can be positive, it can be negative, it can be big, it can be small, it can be everything. Now, to find the ranges for secant and cosecant, we need to remember that they are the reciprocal functions of cosine and sine. So secant theta is 1 over cosine theta, cosecant theta is 1 over sine theta. So we're going to do the argument here for the relationship between cosine and secant, but it would be the same argument for cosecant and sine. So let's take a look. We know that cosine at most can be 1. Now if cosine is 1, then secant would be 1 over 1, which is 1. If cosine was 1/10, then secant is going to be 1 divided by 1/10, which is 10. And if cosine is 1/100th and we plug that in there, then secant becomes 100. And if cosine was 1 over 1,000 and we plug that in, then 1 over 1/1,000 becomes 1,000. So we can see that as cosine gets smaller and smaller and smaller, secant gets bigger and bigger and bigger. So as cosine goes to 0 through positive numbers, secant theta is going to go off to positive infinity. It's just going to get bigger and bigger and bigger as cosine gets tinier and tinier and tinier. Now if we look in the negative direction, we know cosine theta can be as small as -1. If we plug a -1 in there, 1 divided by -1 is -1. If we put a -1/10 in there, then 1 over -1/10 becomes -10. This becomes -100. This becomes -1,000. So we can see as cosine of theta gets closer and closer to 0 coming through negative numbers, we can see that secant of theta gets more and more and more and more negative. So secant of theta approaches negative infinity. Now, when we look at this, we see that secant goes from 1 to infinity, or if we kind of go backwards, from -1 to negative infinity. So the way we say that is the range of secant theta is in the following union of intervals, from negative infinity up to and including -1. That's what this piece over here is. Union from 1 up to positive infinity. And that is the same for cosecant theta as well. So to be clear, what we're saying is this interval is 1 to plus infinity, and this interval is negative infinity to -1. Now here we're going to make a summary for the ranges of the trig functions written in interval notation. Now we know that sine and cosine both had a range of -1 to 1. So if you were to think of this on a number line, that would mean the range of values would go from -1 to +1 and nothing outside of that. Now for tangent and cotangent, the range was all real numbers, so negative infinity to positive infinity. So if we graphed their range on a number line, it would be the entire number line. Every possible value on the entire number line. And for secant and cosecant, remember we had to write their range in two pieces, from negative infinity to -1, union +1 to positive infinity. Now if we looked at that on a number line, we would have -1 here, +1 here, and this piece of the graph from negative infinity to -1 would be going here forever that way, and then this piece of the graph would go starting at 1 and go forever to positive infinity. So nothing can live in between here. So notice the difference between cosine theta and sine theta and secant theta and cosecant theta. Sine and cosine live their entire lives between -1 and 1, where secant and cosecant live their entire lives outside of that interval, so from negative infinity to -1 and 1 to positive infinity. Now in this next example, we have to determine whether each value is then possible or impossible. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. So for tangent of theta equaling -156.8, since its range is all real numbers, we know it can be anything, which means absolutely, positively, yes, this is possible. So I'll put a P for possible. This next one asks if secant theta can equal 0.83. Now remember, its range is from negative infinity to negative 1, and then from 1 to infinity. So 0.83 would fall in here somewhere where they cannot live. So this one is impossible. And lastly, sine theta is equal to negative 0.54. Negative 0.54 definitely falls within the range. It would be about right here, so that is possible.